square wave, right? That was coming out correctly, right?
Yes, sir.
Okay, that means if you take the channel A of ADALM and give it back to channel B and just view the waveform, it will be correct. But the moment you connect it to this IC, right, something is going wrong and it is not working correctly. Okay. So, what do you think is the reason? Well, voltage is okay, no? 0 volt to 5 volt, that waveform is swinging. So why should it not work then? So what could be the culprit? If voltage is okay, what might not be okay? Take a wild guess.
Sir, power.
So what else? What is power determined by?
Current. Current multiplied by voltage.
So there is also something known as a current. Okay. So your ADALM kit is driving this input to the clock of your counter. Okay, 74LS163. Now that okay, Vivek, can you open that data sheet of that 74LS163?
Oh, yes, sir. Sir, is my screen visible?
Yes. Go up. Go up the circuit diagram. Yeah. Here. Okay. Right. So now, what is happening? Let's see. Right. Okay. So now tell me, you are connecting the ADALM output to which input here?
Clock, sir.
Clock. Okay. Now, how many logic gates is your clock driving?
5, 4 to 5, sir. 5, including that inverter.
Correct. So what was happening is the current that is so though ADALM is giving 0 and 5 volt, there is only a maximum current that can be supplied by the kit. Okay. Now if you are connecting it to an input which is drawing more current, then the ADALM kit voltage will drop. Okay, because essentially power will sort of, in some sense, energy is always conserved. Okay. So to a first order, you can think of it like that. So if I draw more current, then the voltage has to drop because V into I is the power and multiplied by time is the energy. Okay. So therefore, if your current increases, if the circuit here, the ADALM is driving, the current increases, then the voltage will drop. Okay. That's why that counter was not working when driven by ADALM directly. Now what we have done, we have put it through this thing, right? We have put it through this other chip, which basically is, what is that chip? It is again. Can you open that data sheet? Go up. I want right up. I want up. Wait.
Sir, for which one you are talking about?
This one only. Wait.
Oh, okay.
No, go up. Go right to the top. Uh, One second. Where is this? So, okay, essentially what happens is this inverter here will work with much smaller, current compared to the inverter that is there in that 74LS163. Okay. And that is the reason when you add this chip in the path, everything becomes all right magically. Okay. Is that clear?
Yes, sir.
Yeah. So any questions in this experiment?
Yes, please.
Sir, there was just a small doubt in the sir, these 2 points, ENP and enable P and T. So can you please explain what are these?
Yeah, so that you have to look at the data sheet. Even I am not sure of what they are. Just go to the thing. So this experiment, one of the goal is for you to read the data sheet and understand what is there.
Yes, sir.
Okay, so just go down. I think it is there. It is there. There's a table somewhere, right? There'll be a truth table somewhere. Down, 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 down. Wait. Go up, go up. Stop. You see this? You should be able to make out from this waveform. You see ENP,
Yeah.
what is happening, right?
Yeah, sir. We need to analyze it.
Okay, so you read the data sheet and figure out what they do. Okay?
Yes, sir.
Yeah. Okay, anyone has any questions on this experiment?
Yes, sir. I have a question.
Yes.
Yeah, basically, I have a slightly different opinion on this current loading capacity because the ADLM can drive up to 500 milliampere current.
Yeah, we
yeah.
believe that is wrong.
No, I checked it. There is one more aspect I want to look into.
Okay.
Because in this particular IC, it is only one TTL load. Even though there are multiple things it is clocking through one inverter.
Inverter,
So it is actually, so it is only one TTL load.
Yes.
And another thing is, these amplifier which they are using is a very high slew rate amplifier.
Yeah.
Those devices need to be carefully, finessely handled. So, and another thing is what I found is it is around 1 volt. There is quite a lot of glitch on all transitions. Is it because of the hardware or the firmware or the driver? We don't know. But what exactly is happening is there it is now you have introduced a mid trigger because of the hysteresis, not because of the current driving capacity. It is because of the hysteresis involved. We are able to get away from it.
No. I'll tell you. So I did a lot of experiments. So one thing is, one thing is that, see, when I did the experiment in the laboratory with the traditional oscilloscope, traditional signal generator, traditional power supply, and all that. Okay. So you may be right that the current need not be the only reason for this. Okay, I admit that. But by adding this chip, the problem got solved. So I still agree that there could be some other reason. But there was no glitch essentially, because what I'm trying to say is I observed the output of ADALM on the oscilloscope.
I have also done the same thing, sir.
Okay, because I don't remember seeing that kind of glitch at all.
I can show you the screenshot if you want. I'll attach it in my report.
No, please do it. I think the idea is to analyze these things and come up with a solution. But in at least the kit, so what I did was last time we ran the lab, students had the same problem. So one of the students who were in Chennai, I brought them to the lab and I took their kit, connected it to the oscilloscope. I had my own external signal generator, external power supply. I did all combinations and checked. And
Okay.
ultimately, it was this ADALM which was not able to drive a load. Because when I checked the output waveform, see what I did was I took the waveform from the channel A and gave it directly to the oscilloscope.
Okay.
And that did not have any of these, glitches or anything like that.
If you concentrate on the edges, it is there, sir. I have captured it. I will attach it in my report also.
Yeah, please do that. Please do that.
I'm very firm. I'm quite confident that this is something like that. It's more to do with
excellent. No.
There's one more reason. There's one
Yes.
more reason why I come to this conclusion is I have loaded the output with 50 ohm resistor. That means it's quite a lot of load. One
Yeah.
TTL load is hardly 4K or 5K. This is 50 ohms, 100 times that. Still, it was driving. And when I zoomed in with a 500 megahertz oscilloscope, I could find on the edges there are minute glitches, which exactly falls on the TTL logic levels. Now that we have put a CMOS IC in between, the logic level has changed totally. And added to that, we also have a history resist in the chip.
Yeah, correct. So what we have done is put a CMOS to TTL converter. Correct.
Yes.
Okay.
That is why it has gone. I think I am doing it with this thing only. I am trying to find a solution if I can drive it through the channel A or channel B without any other hardware. If it is not there, then I will drive it through the digital.
So I will tell you one more observation that we had from last time. Why we thought it should be the current. Okay. Now what you do is you take your ADALM kit, channel A, channel B, drive the same, configure both as a signal generator to generate the same square wave.
Okay.
Short the two outputs.
Okay.
Okay, channel A, channel B, and give it to your counter now. Okay. You will see that the counting is actually better. So what will happen is, so there are certain counting patterns that require more current than the others. Okay. So this will now count 0, 1, 2 or something, and then it will start failing. Something like that happened. So if what you are saying is correct, that is based on hysteresis and all that, then tying the two outputs together should not matter, right?
That can also shift the voltage level, sir, slightly.
Okay, yeah. What I'm saying is try that experiment also and see. I would be more than happy to, nail this issue down correctly.
Yeah. I think I have got a solution. I'll attach it. You see my report. I think you will understand that.
Sure.
Yeah.
Okay. That's the reason I am involved in the live session for the first few sessions. I mean, first few terms, because I want these issues to be ironed out properly. Okay, then instructor can also run it. But I would very much appreciate and welcome your inputs on this issue to nail it down properly. Okay. I had stopped last time reasonably sure that it was a current issue. But if you think otherwise, let us debug further.
Oh, yes, sir. Thank you.
Okay. Thank you. Yeah. Yes. Anyone else? Questions?
Professor, one more observation.
Yes.
Sorry,
before I finish, who was the previous person who spoke? Sorry, who was the previous person who had this suggestion?
Yeah, I am Narayanan.
What are you doing, sir?
No, I have quite a bit of experience manufacturing electronics. I'm not qualified in electronics.
No.
What
are you currently doing?
I am having a manufacturing unit in India, in Chennai.
Wow.
In Guindy.
Okay.
We manufacture electronics for various OEMs.
Okay, excellent. Very good. We would very glad to have you here. Thank you.
Yeah, I have 35 years of experience in this industry, sir.
Okay, excellent. Very, very nice. Thank you. Yeah. Yes, Mr. Raja.
Yeah. Professor, one more observation what we had is,
yes.
From the A, we first generated the square wave and fed to the CMOS IC and given to our normal IC. Okay.
Yeah.
During the time, it was working fine. And one
Yes.
more observation is the channel A was fed through the sine wave. During the time also, it was working fine. So the CMOS IC is perfectly generating the or converting the whatever the waveform coming from channel A to the square waveform. So
Correct.
that is the one of the observation.
Yes, correct. Yeah. So even if you give a sine wave, it will get converted to a square wave with a different duty cycle. That's all.
Yes, yes.
Yeah. Correct. Yes, that's a valid observation. Yes. Very good. Anyone else? Any other comments? I hope all of you who have managed to finish this experiment, can you please raise your hand? All those who finished the experiment were able to do it. Please raise your hand. I can't believe there's only one person. How many of them?
Sir, I think I am not able to raise my hand due to some issue.
Okay. Okay, what about the others? Harsh, Hariharan, Gayatri, Thakur. Were you able to do it or not? That's all I need to know.
Professor, experiment completed, but could not raise our hands.
Oh, okay. Fine. Then it's okay. Fine. Actually, just type on the chat that you are able to do it. Just say done. Okay. I think a good number of people are doing that. Okay, great. Any other questions for today then? So what?
Sir, Namaya is not in the meeting, I think, but he has done it with the same with the 555 timer.
Yes. So it is like I said, see, this experiment is very simple, right? The idea is to see that voltage is not sufficient. There can be other issues also, which could be current, or like that gentleman said, it could be something else which we need to look at. Okay. But just because you get a voltage that looks okay, it doesn't mean everything is okay. That's your main learning from this experiment. So also try to generate the waveform from your 555, for practice here. Ultimately, when you come for your evaluation in September end, right, you will be asked to repeat this experiment with something else, with some additional part. So if you cannot generate this waveform properly, you're gone. So make sure you are able to generate this waveform in 2-3 different ways. Okay, one is using this CD chip, CMOS to TTL converter. Other is to use the 555 timer. The third one is to actually configure the digital pins of the ADALM kit itself with some Python code. So Victoria, can you share that thing that these people did last time?
Yes, Professor, I will share it with you,
Share
Professor.
the code and all that stuff so that they can try that also.
Okay, Professor.
Yeah. So for this experiment, I want each of you to generate this square wave and show me the counter output in 2 ways. Either this CD whatever and 555, or 555 and the Python code, or Python and CD whatever. 2 ways I want to see the output. Okay.
Okay, sir.
Great. Okay. Very good. If there's no other question, then we can close for today. Okay. I will see you next Monday. Will be the unlock experiment again. Okay.
Yes, sir.
Thank you all.
Thank you a lot, sir.
Bye.